Hi everyone, it's Nana here and welcome to the machine learning series. Today we're going to go into session number 10 and we'll be covering things that have to do with machine learning, creative coding, and other things that have to do with design, art, and we'll see. So again, this is part of the machine learning series. We're at week 10, so it's already been 2 months and a half since we started. And I first want to start, as always, to reminding you that if you like this content and this is the type of videos that you would like to see in the future, go ahead and like the video and subscribe if you want to get notified when new videos come up or when I go live next. And also would like to invite you to join the Discord server, the community at none.of.ma/Discord. I'll do a pause here because this has happened before. We've had some internet technical problems today. Can you hear me okay? I will wait until you guys tell me if you can hear me okay, and then we'll keep going. All right. So let me just check that there is audio here. It seems like we have audio. All right, let's keep going. Over the past weeks, I've been starting to ask for questions from podcast listeners and blog readers. And this is the first ever question that I've replied to or answered to on the podcast. During your commute, do you listen to music or podcasts? There is a new episode that is available today on gettingsimple.com or wherever you get your podcasts that you can listen to. It's like 13 minutes and it's just a Q&A that I actually recorded live in this video series, and then I edited and post-processed for the podcast. You also can go to see live number 9. I think this was a quite interactive one. It didn't really cover that much technicalities as of typing code. We looked at Teachable Machine. That's a code base provided by Google in which you can create a data set. It gets automatically formatted. You can train it on the web and then you can test it. And you actually train an image classifier from start to end on the web. So this is a really good place to start if you don't know anything about machine learning, if you don't know anything about coding, and you just want to get going with creating your own neural network by training with your custom data set. And then we also see in this video how to use that model, so to export that model and use it somewhere else, or at least visualize it. You can go to previous videos as well if you want to see how to use a neural network that is an image classifier that you've trained somewhere and you export to the Keras format. I think in live number 8 we actually show a Python notebook on how to do that. All right. Last week we covered Teachable Machine. We're going to see a few things today of this, just things that we didn't cover that are a bit more advanced or things that I want you to know about. And we also showed Netron. You can go to last week's video. I'm not going to show that today, but if you export a neural network from Teachable Machine or anywhere really into the Keras or tf.Data.Dataset format, you can use Netron, an Electron app that you can download for free to visualize your neural networks. And we've been covering TensorFlow.js. It's a library for machine learning in JavaScript that you can use on the web. Today we're going to see ML5. We saw it before on previous videos, what it was at least, but we haven't really gone through coding with it. We haven't done anything. So that is something we're going to do today. So, okay, let's get to code. And let me just see here what we have. I have a series of notes here. I'm going to zoom in just in case that you cannot read them properly. This is live 10. So we'll see. Blotter.js is something that I might go and test today because I've been looking at it for the past weeks, but I haven't really implemented anything with it on the web. This is a library to make these really cool effects. So you can see they call it a JavaScript API for drawing unconventional text effects on the web. And you can see these are web shaders. So if I zoom into here, these are actual web shaders running on the browser that are making live effects to these fonts, right? In this case, this is an effect called alpha channel splitting. So we got the RGB channels separated into 3 according to the mouse location. from 0 to whatever range and on the angle that we're interacting with the script. It's pretty cool. If you go to overview, you can get an overview of what this is. Basics, it tells you some of the basics of how the library works. I haven't used it, as I said before. And then materials. So these are the main materials. Let me just zoom in here so you can see. So we have the channel split material, files material, liquid distort material, sliding door material, and rolling distort material. And these are things that probably just using, Blotter material describe how your text will render and provide an interface through which you can introduce variety in these characteristics of any effect. And then we go to documentation. We actually see, the documentation of the API that we can use to use Blotter to code. All right, that's Blotter. We haven't used it yet, but might do that today. All right. Teachable Machine, there's things like customizing the training settings, activation maps, and confusion matrix that we didn't get to see yet. There's also the Teachable Machine wizard. That's a hello wizard, shows you how you can add machine learning or the training process of machine learning and the machine learning model executing on your website to your site on a few lines of code. And then ML5.js. As I said, we're going to try to train a classifier with code in a way that we could automate it with JavaScript. We're going to take a look at DoodleNet, maybe as well at CVAT and Spell.ml. So Spell.ml, I'm not going to go into detail on it, but just going to show you. This seems to be a platform where you can manage your training jobs on machine learning. And the interface, this is a mock-up here. The interface would be something like this, where you would have different jobs that you can launch and runs, and you can probably do hyperparameter tuning or fine-tuning your models. Looks a lot like what AWS SageMaker is allowing you to do, but I really like this interface, and I discovered this through Jennings repository here. So the repository for this demo that we're going to see today. All right, let's keep going. So let's follow the order. So Teachable Machine. We mentioned before that we saw this interface last week. This is an interface where I chose or put two different classes, color sketches and black and white sketches, and we train a model and try to use it. And what we're going to do is that we're going to go back to that interface. So yeah, so I have here, so this is the model that we trained last week. And okay, this will make me probably disappear from the other camera, but we'll fix that later. So what we have here is that the input that we're getting is from the webcam, but what we want to do, and it's telling me that I'm a color sketch in some way, which, it's not really, doesn't make a lot of sense. But if we go into file selection, we can choose a file from our disk, and we could go into our live folder for live number 9, I think. Well, this is the classifier code. I think maybe in live 4 we have this data set. Yeah, so if we get a test image for black, right, so we get that this is gray. And let me just see, so we have that there. And if we select a test image on the white folder, so on the color sketches folder, we can see that that's a color sketch, right? So what's happened here, just as a recap, maybe you didn't watch the video last week. This is a model that we trained and Google is serving for us in this page. And we have a unique URL that you can open on your browser. So that's at teachablemachine.withgoogle.com/models/15QRF2SAK. That's the unique identifier of my model is here, and anyone can open it, and you can also use it in JavaScript. And that's something we could try today. So see this link to learn how to use teachable machine models in your projects. Let's go open that. So, we already saw tweaking your model. Yeah, okay. So this is just you can learn a bit more there. Our model, in summary, our model has these Okay, let me just take a look here. So it seems like every time a browser tab uses the webcam, it gets the configuration goes awry. And okay, yeah, thanks. Hello, Bea. Hello, Suje. Hello, Major. And it seems like you can hear me right. The webcam, yeah, the webcam is going to get with the wrong settings when I activate the webcam mode in this drop down, because it will try to load the webcam on the browser instead of on the streaming software. All right, let's keep going. So as I was saying here, we have the model.json and the metadata.json, and then also the model weights here. This defines the model architecture, some of the metadata that you might need to know what the model does, the classes and stuff. And then the weights are the saved weights of the model that the model actually uses to perform inferences, right? So if I go to Teachable Machine, what we're going to do is, because it was really fast, we're going to go into an image project again, and we're going to just train this. So I'm going to move myself to the right. And what we're going to do, again, we're just going to do the same that we did last week, but really, really fast. So we're going to upload our image of color sketches here. We're going to do the same with the gray ones. And here we're going to load the blacks. So this is grayscale images and color images, and we could add more classes, but we're not going to do that right now. So if we go into advanced, we have here a few settings that I didn't really comment on last week. So these are the epochs that the model is going to be training, the batch size, the learning rate. And we can read here some information about them. Just make that big. So one epoch means that each and every sample in the training dataset has been fed through the training model at least once. If your epoch are set to 50, for example, it means that the model you're training will work through the entire training set 50 times. Generally, the larger the number, the better your model will learn to predict your data. You probably want to tweak, usually increase this number until you get good predictive results with your model. All right, so let's focus on the epochs first, right? So we have 50, and we can click here on training model, and we're going to see after these trains, we're going to be able to see some information about the model. And all right, my webcam went here again, so we'll lose it and under the hood. Okay, so yeah, so these that we have here, so let me just try to see if the file option just stays. All right, so we're gonna have to be doing this a few times if the browser gets the webcam. So accuracy per class, calculate accuracy per class, calculate confusion matrix, and we have the accuracy per epoch, accuracy 99, right? And we have the okay, let me move again. All right, so let me zoom into here. What we can see here is a graph that Teachable Machine is auto-generating for us, where we can see the accuracy over each epoch. This is like the log while we're training, and here we have the loss per epoch. The loss function is well, let's go first here. So the accuracy is how accurately your model is classifying each of the samples on what's called the validation set, whatever set is being used at every epoch to measure whether they're being classified correctly or not. And the loss per epoch, so the loss function is a function that measures the error, so how much error your model has, and we want that to decrease over time, right? We can read a bit more here. Loss is a measure for evaluating how well a model has learned to predict the right classifications for a given set of samples. If the loss is 0, predictions are perfect. Otherwise, the loss is greater than 0. To get an intuitive sense of what this measures, imagine you have two models, A and B. Model A predicts the right classification for a sample, but is only 60% confident of that prediction. Model B also predicts the right classification for the same sample, but is 90% confident of that prediction. Both models have the same accuracy, but model B has a lower loss value. All right, so yeah, the more the more confident your model is about a prediction, the greater the loss that is on the model, right? So let's see. It seems like the loss stabilizes after epoch 20 in this data set. And what we can see here is that if we say, okay, let's train for 100, let's do 200 epochs, and then train the model, I don't really know if we're going to get this live. Yeah, so we get this animation live, right? We can see that the test loss, okay, all right. All right, so the accuracy, the one in blue is the actual accuracy measured on the data set that we're using for training, and whatever images the model is reserving for testing or for validating in this case is the orange one, right? So there is some piece of our data set probably that is getting classified wrong all the time. And what you can see is that if we go to the loss in the epoch, after epoch 3 or something, the loss goes up, probably because something is being misclassified on the test set. That we can maybe with the batch size or the laning rate we could improve that. Let's just try it. But it seems like there might be some bias on the data set that we're not going to be able to get any better results. Okay, this is just making it worse. Let's see if a smaller learning rate seems like 0.001. All right, so let's just see, maybe a 5 here. So this is like half of the default learning rate that we were getting before. All right, maybe let's try with the batch size. So here I'm just playing with the parameters, and I just want to visualize how each of these different parameters is changing how the model works, or how the model performs after training. Right, this makes it a lot worse. Test accuracy is the same, loss per epoch. Right, so it seems like these are the optimal parameters that we can use for what we're doing right now. Oh, test loss is really bad. And I'm not sure how this this application is actually calculating what's on the test set, so on the training set, and what's on the validation set that this is using for testing. But it might be that they're shuffled around, and each run they're different, and that's why we're getting inconsistent results. Right, so this seems like it's still really high test loss. Right, what did we do before? So let me just see on the learning rate. Okay, so let me see here. So it seems if we look at the confusion matrix, right, in here we can understand a bit better what's going on. So there are two images out of the 5 that are being tested with that are being classified as gray, but should be color, right? So in this way, the confusion matrix allows us to understand what's going on and why the loss is or the accuracy is not working well. So I guess, like, let's see, right? So there are two samples. There are 2 samples out of 10. So there are 10 samples here on the confusion matrix that we can see. They're that are being classified as the wrong thing. So 2 out of 10, and that gives us, 80% of them are being classified properly, 20% of them are not. And what that gives us is a test accuracy of 80%, right? We're classifying only 8 out of each 10 properly. But that might be influenced by what images have been used on the confusion matrix, right? On the test data set. So let me actually do one thing. Let me just go back and reload this page. We're gonna do the same once again quickly and upload images. So these are images, all of these ones, and then all of these ones. All right, so after we load these ones, we're just going to train. Okay. And it seems like the loss is not great either way. I think we got better results before. And now we're getting more misclassified items. So we're getting now 3 out of 10 misclassified. All the gray ones are being classified properly, but the accuracy is lower on the color one. So only 2 out of 5 are being classified properly. All right, so what could we do for this, right? What I wanted to show today is the accuracy per class and the confusion matrix. One thing I would like to see also are the activation maps, but I don't think we're gonna do that today. And what you need to see is that these are useful things that you can calculate anytime that you're classifying. So anytime that you're training an image classifier, because this allows you to understand what's going on. This model, at least with this training run that we have that just happened, out of 10 images I was using for testing, just misclassified 3 that were on the color class. And there are ways in which we could improve that. One way would be like we augment the data set, so we try to create more permutations of the same data that we have right now or add new data in an attempt to provide the model with more images to train with, so it knows a bit more about what color and black and white images are. So let's just try to augment the data set. And let's see how we can do that. So let's try to do that with TensorFlow. So what time? All right. Data augmentation. Right, so really quickly, what we have here is a sample. It's actually a neural network, or like a Keras sequential model. That probably not neural network, just like a Keras sequential model that does data augmentation operations. So it does random flipping, so it rotates, so it flips the image sideways and horizontally randomly. So it might do it or not, it might do one or not. And then it also does random rotation, so it rotates a bit the images that we're using. So let's actually do this. I don't think we really need to do this on the cloud, so I don't really need to go to Colab, even though we could do that. But what we're gonna do is that we're gonna go and create a new folder here. So I'm gonna do live number 10, and I'm just going to, okay, let me make this bigger so you can see. So what we can do, just to recap, the exercise we're trying to do is just to augment the dataset, just to see if we can get better accuracy on that model with the same parameters. So even leaving the training settings as they are in here, what we want to do is see if we can improve the accuracy we're getting here and the results of this confusion matrix. All right, so let's go back to our terminal and list my environment. So these are my Anaconda environments, and I'm gonna activate the one in which I have TensorFlow installed, and I'm just gonna run Jupyter Lab to execute Jupyter notebooks on my machine. And what we're gonna try to do is just run a few of these operations to augment our data set. All right, so quickly, let's go to this directory. We have our data set here. And what we're gonna do is we're gonna grab our color and black and white images. We're not gonna touch the test images, and we're gonna bring them here. So the dataset raw. I'm gonna put that here. Okay, so we have Jupyter Lab, we have our dataset raw with our images, and what we want to do first is create a TensorFlow 2.3.1 notebook. And we're gonna see what this tutorial does. So I haven't gone through this before, but let's see it. So this tutorial demonstrates data augmentation, a technique to increase the diversity of your training set by applying random but realistic transformations, such as image rotation. And you will learn how to apply data augmentation in two ways. First, you will use Keras processing layers. Next, you will use tf.Image. All right, so Keras processing layers. Let's see what that is. Download a dataset. We already have a dataset, so we're not going to go through downloading it. We are going to all right, so we have classes, get label. All right, we're not going to do that. So using Keras processing layers, we have option to resize and rescale, and we have options here for random flipping and rotation. Okay, you can use pre-processing layers to resize your images to a consistent shape and to rescale pixel values. All right, so we're not gonna do this because we already have our images on the size and format that we want. What we're gonna do is data augmentation. You can use pre-processing layers for data augmentation as well. Let's create a few pre-processing layers and apply them repeatedly to the same image. All right, so I'm gonna put this on the side so I can follow, and you guys let me know if this is making sense so far. So what we're gonna do is we're gonna create a data augmentation model. That's going to be a Keras sequential model, and I'm gonna go this way. And inside of this model, for those of you who haven't seen previous videos, what we have is this syntax here that says tf Keras sequential, and inside of it, the first parameter you can put, you can create the model and then start adding layers to it. But what I prefer to do is just to create the model and then add an array of tf Keras layers. So we can, for instance, say here tf Keras layers, and then we could do an input layer or a dense layer or something like that, right? In this case, what we're gonna do is that we're gonna try the experimental pre-processing layers. So we have this here, and our first pre-processing layer is gonna be a random flip, and we're gonna choose the option horizontal and vertical, right? So let me see if I can make more room here. And yeah, so that's gonna be the first one. So let's keep going, and then the second one is gonna be tf Keras experimental pre-processing random rotation and 0.2 as well. Right, so we define this model. First thing I'm gonna do is to try to see if we can get a summary of this. Model has no attribute pre-processing. All right, this is actually layers. This model has been built. Okay, so we haven't really compiled the model, so we cannot get the summary. Haven't built the model. And next I'm gonna go and add the image to a batch. Yeah, so first here to test the model, we're gonna load something from here. So we're gonna get, for instance, this one, copy path. Let me see. So this is the path, and we're going to import. So from pil import image, we're going to load pil, and then we're going to say, okay, my image is this one. And then let's see. Yeah, so I have an image here, and with this image we just want to pass the image through the Keras sequential model, and we're gonna get an error if we don't augment the dimensions. So what we're gonna do is input tf expand dimensions of this image on axis 0. Right, so this is an image, it's not an actual tensor. So we needed to do tf Keras. Right, and now this is a tensor with our image. It's a batch of images, so it's a batch of 1, and hopefully we can now do this and say output data augmentation input, right? And our output is a tensor. So if we get this, we have our image. So let's see if we can do. Let's see if we can convert. So let's recap a bit here. So what we've done is we have loaded pil, we've loaded an image from its path, so we've hard-coded that, and we have converted the image to an array, so we can load that as a tensor in TensorFlow, and then we've expanded the dimensions of that NumPy array to make a batch of 1, right? So this creates a batch of 1 by height, width, and 3 channels. That we can see here, the size was 400 by 400 in my dataset. And now this output that we have here, so what I'm trying to do is convert this array back into an image that we can visualize. So array to image output, and that. All right, so our image has been augmented. So it seems like this image has like a slight border. I'm not sure if that's something intended or if that is an error or it's just this data. But yeah, it seems like it's adding that border to all of my images, which is something that we probably don't want on our images. And I'm not really sure why that's happening. And that's something that we probably wouldn't want to have there. But let's just ignore it for now. Okay, so this seems to be working. So it's randomly flipping and rotating, and this way we'll be able to perform different data augmentation operations. As you can see, for each time we run this, the images are slightly different. And what we can do with this, as they do on the tutorial, is that we can actually make a loop and say like amount might be like 9 per image, and let's say for I in range amount. So we're going to create an image. So augmented image is going to be this data augmentation for the output. And what we're gonna do is make a plot. So subplot, we're going to get 3 there plus 1. This is the axis, and then we're gonna show each of the images augmented image 0, and then we're gonna plot without the axis. All right, let's see. Plot again, and again we need to import matplotlib pyplot as plt. Right. Okay, so we're getting our images in. These are rendered like this because they're not RGB. They're actually black and white, and they're being rendered with one of the weird color maps. Yeah, so this is our augmented, right? These are our augmented images. And what we're gonna do right now is just try to save these images, and there are a variety of let's take a look here. So there are more, so we can get like random contrast, random crop, random zoom, and others. And we can go and see which other layers we might wanna add. All right, random height, random rotation, random translation, random zoom. Let's just try some of these ones. tf Keras, preprocessing, random zoom, height factor, width factor, fill mode. Okay, let's try this one. Random zoom, for instance. Okay, so we, to try one of these ones, we just have to add it here. So say random zoom, and then we can say maybe 1.1 or like probably 0.1, and the width factor is going to be also 0.1. Okay, and I'm gonna make it a bit bigger just to make sure that this is doing something. Yeah, you see, so this is actually now zooming in and out, and this way we won't overfit our data set into something that just looks like the images that I had on my dataset. We'll see a lot more. And I don't like those edges that we're seeing here, but we're not gonna care that much about them today. All right, so let's see if we can quickly save this. Right. So what we can do then is we're going to load all these images, and let's see what's the best way to do that. What we want to do is load the images that we have on one of the folders into a batch of images, and then pass that through the data augmentation script. To load, so dataset loader TensorFlow. Let's take a look. Oops. All right. Okay, so we have this tf.Data.Dataset that we can use to load a set of data. So list file, dataset of all files matching a pattern. All right, so this is what I was looking for that I didn't remember of. So we can call this thing and just put the path here. So say, so the path that we had to that folder in here. So dataset raw, black and white, and we'll try to load everything that is a JPEG. So we'll make here a wildcard.jpg. And then our dataset is shuffle data shapes, whatever, JPEG. TF string. It doesn't seem like this is working. So list files, path, txt, dataset raw, black and white, .jpg. Shuffle dataset. Argument should be small number of glob patterns. If your file already have been globbed, use from tensor slice instead, as reload every file name with list measures and import performance. We had the following patterns in our system: will pass, path. Right. Let's just try this just in case the spacing is. Okay. You guys have any clue why this is not working right now? List files. Oh, there. Okay. Let me see if this does it. So if we do here import OS, import the operating system, and we do here OS list there. Yeah, okay, so let me just see what we're expected to get, because I'm not sure if this is working and we just don't realize it. Oh, okay, so this might actually be working from the very beginning. So we have to now map. So map function, non-parallel calls. All right, so let's try to do this map and load image function. Okay, so we gotta define our functions. So def load image. Let's just make a dummy function here. Okay, so now we got images, and we have 3 integers. Map dataset shapes. Okay. All right. So it seems like we're getting somewhere. So I have here a dataset loader that is able to, not sure if this is working like this, but we're just gonna do this once again. All right. So it seems like now we, the dataset loader was loading the dataset before as well. I just didn't realize it. So by using this glob pattern, so just putting the path to the folder and then the asterisks here, it's telling this dataset loader to just load every single image that is on our folder. And then later with Dataset.map, we just pass each of the data pieces that are on that folder into a function, into this function here, that is loading the each of the images and then passing it through this processing function that we do, right? Like whatever we write here. And what we can do, because I just have it on top of my mind, what I'm gonna do, I'm gonna just try to do this here, so, and see if we can just return this. Right, so we have an error, tensor has not read. All right, so all right, I'm gonna make a quick pause here. Let me just remind myself here. So I forgot right now how to do this, but I remember seeing it here, so I don't want to waste a lot of time with that at the moment. Okay, so what we get here is the image already. Oh, okay, so let me see. Let me just try to do this. Okay, so we have a string path. So what we're getting are the binary file, right? Okay, so what is happening at the moment is that we're getting our the image paths. So image path here, and that's exactly what we can see here. So what we need to do is to use that string to load the image. So we have done this before. Where have we done that? Where do I have that? Okay, so let's scroll back a bit and just rewrite this function. So let's put this in order. Let's just put it here. So to our loading image, so we have the image path, we import OS, and then we map the dataset, and then we loop through them. Okay, so what we get here, what we can do is that we have the image path, and what we can do is read the file from that path. So we actually have the image path, and then if we just return the image, then read file. Ooh. What? Okay, so this has been namespaced into the .io namespace, and then we get, okay, so we're now reading the data from those images. So we're listing the paths of our images in here. Then we're running in that data set, we're executing the load image function that is defined here into every single file. And right now what we're doing is just using the path of the image to read the file, so the binary data, and then returning that as an image. But that's not really an image, it's just the data of the image. So what we need to do now is call the decode JPEG in this case, and say call image, and then channels, say 3. But I'm gonna leave this off just in case the black and white images only have one. Then we return that, a TensorFlow decode JPEG. All right, so again, we need to namespace this. So we're in the image namespace, and then we have the image data. Okay, so now what we could do is, so let me just see if I can preview one of these images or what happens here. Let me turn it on scriptable. Right. Okay. And so we have the image here. We haven't resized it because it's not necessary. We already know what they are. And let's see if we can here print the eye shape. Okay, so we have images that are 400 by 400 by 3 pixels. What happens if we put here black and white? Okay, some of them have one color channel, so they've actually been exported with only one channel, and that would be a problem in our, if we pass it through a network that wants the entire batch to be like 400 by 400 by 3 or by 1. So what we can do here is that we can do tf image resize, say image, and then I think we need to put here this shape, right? Let me just look at it, what it was. So I have the autocomplete off, and okay, size. So size is going to be 400 by 400. And here we'll say, let's just try to force it to be 3 channels. Okay, so actually maybe we don't need this one, we just force the channels. Okay, so we have everything now is 3 channels, so RGB, even if they were black and white. And we can safely now try to obtain the information that we need to export our augmented dataset. So right now we still don't have a batch of images. Let me see how to obtain the batch of images from here. So if we batch, all right, so batch. Okay, so let's see if we can just call here and say dataset batch 4. Okay, so we get tensors with those. We want not this, but the images. Okay, so we get bat shape. All right, so now we're getting batches. So what we're gonna do is to see how many images we have. So can we do that here? Can we actually just count how many images we have? 30. All right, so we're gonna do a batch, and I'm not sure, range 8. Okay. Cast batch as NumPy iterator returns an iterator which converts all elements of the dataset to NumPy. I just want a batch. All right, let's just try with the batch. So if we do this, so we get dataset, so we say images batch, and then we say the length of images, so that would be 30. What do we get? We get batch shapes, none, 3. And all right, let's see, we do this again. Okay, you see how the shape on this data set is none, 3, even though we know that the shapes are 400 by 400. That is because we need to specifically define that the resize, so the size of the images is 400 for this to show the actual shape. None, we want it to be none on the first axis because that means that it will accept any amount of images, but then we want to know that it's 400 by 400, and that's what happens if we specify that resize operation at the top. So if we get images, can I get the first batch? All right, we don't. If I do this, okay, and okay, so for batch in images, or let's actually just do this, we're going to print the batch shape. All right, so we have 1, 1, 1, 30, 40. I don't understand this. Okay, that sounds good. Cool. So let's just put this here and try to see if we can okay, yeah, I can not do that. So what I'm trying to do to come up to is that I want to have a variable or like a tensor batch that just has the, just has this shape, the 30, 400, 403, without actually having them on a batch, right? Because the dataset loader just lets you create batches. So here, if we were to say index index 0 and then put index 0 plus 1, so we can say here we have, let's say, batch and then index plus 1, right? So batch 1 has that, and if we, instead of saying 30, so the batch size that we have right now, this is 30, if we instead of 30 set this to something like, let's say 3, we'll get 10 batches, right? So we'll get 10 batches of 3 items of the same size, and then we can run this operation. So for instance, if you have like a huge data set of like thousands of images, you might not want to create one batch and then perform an operation on it. You might want to batch and create different ones. And this is actually done for batching a big data set. So on every epoch, you're actually feeding some items of the data set and not all of them. But in this case, we're going to go with 30, and we just see how many items we have here. So we have 30 items. Okay, so now that we have this thing here, we could pass our batch through the data augmentation operation, right? So each image on the batch, and so let's see. So we can say for each batch, we have that shape, and then we can do data. So let me see. So augmented Where is the code? Okay, it seems like I deleted something. Okay, so let's see. Augmented batch. We can go back to the data augmentation URL I had before. Okay, so we want to just pass this through. Where is our data augmentation? Yeah, so this data augmentation function. So we want to pass our batch through it, right? So if we do this, we can see that the augmented batch shape is the exact same, and that difference in between logging each of the two is the time that it takes to feed it through and generate the images. It's like really fast. And you know, again, we could say, okay, we're gonna do batches of 3 items and then process each of them. It's also really fast. But for now, we're just gonna do 1 batch. What do we do with these images? Now we got to save them. So for each image on the data set, so for image in augmented batch, we want to print their shape, for instance, right? So we have all these 30 images, and then we want to save them. So output directory, and what we're gonna do is maybe just let's actually make a function that we can reuse later. So we have here directories are gonna be this one and the color one. So we have 2 directories here, so color and black and white. And then we're gonna say for directory in directories, we're gonna print that directory. Let's see. All right, so we have these 2, and we're gonna remove that from here. So what we want to do now, let's just put our imports all together at the top, and this one's okay. So let's remove this one here, remove this one. Okay, we have this here. I don't know why it got compressed. And this is the way that we can, in which we can visualize our image is working, right? All right, so we have these 2. We're gonna copy this to the bottom, delete this one. Let me see if I can do that. Yes. Okay. Okay, so we want to loop through the directories, which we have here, and then we're gonna do this process of loading the data set inside of each directory. So we'll do here augmenting images in directory, right? So augmenting images on, and we'll get that printed at the bottom. Hi Pedro, nice to see you around. And yeah, so let's see, let's quickly recap what we're going through here. So we're let's delete this one. So we have a Jupyter notebook, we're loading all dependencies, we have TensorFlow 2.3.1, we're creating a set of, adding a set of layers that are so a TF Keras sequential model, and these are operations that we can find in the experimental API of pre-processing layers in Keras. There's like different types of operations that we can do. We have here a load image function that gets a tensor string, so like a string that is loaded as a tensor, and we just read that file, we decode that as a JPEG and force it to have 3 channels, and then we resize to 400 by 400 and then return the image. And this is an image that we pass later to the Dataset.map function. we go into here. So directories, we're listing 2 directories, the black and white and the color. These are the 2 directories that we have here at the top that we have our images in. And what we're going to do is that we want to get this dataset to load those images inside of these directories and augment them. So create permutations of them that we're going to add to our training set to go to Teachable Machine, and make sure that we get better accuracy than we were getting before. All right, so far we're up to here, and we're gonna get the path of our directory here. So format, and we're gonna get that directory, and we're gonna print this here. So it's good to know that. So glob pattern is this thing here, and then we put here glob pattern. But first we're gonna print it just to make sure that this makes sense, right? So this is our glob pattern for each directory. And right, deleted row line. Okay, so now we have our data sets or images, and what we can do is we define our batch size. That is going to be the length of images in each directory. We can maybe move this below here, and we could do something like this, augmenting, and then put the count of images, so length of images. And let's see, so 30 and 32 images, what we have in each of the folders. And then output directory, output directory we're not going to do it yet. And if we go here, we just want to do the same that we were doing before, but for both of the folders, right? So we go through each of them and do the conversion and then loop through the images. We don't really need to do this last part here yet, and don't need to do this. All right. Okay, so cool. So now we have these 2 datasets are being augmented, and what we want to do is save those images. So what we're gonna take a look at is how to save one of these images with TensorFlow, using TensorFlow. Right, let's actually just save file, encode. I think it was we need to encode the image. And then save it. Okay. All right, so what we will do here is that for each image in the augmented batch, let's actually get, so in the augmented batch, let's just get 1 image and then print the shape just to make sure that we're not processing too many images. Okay, so this is 1. If we set this to 2, we'll process 2 of them. And what we want to do here is that we will be able to do something like encode JPEG, and then we could just pass our image, and then we can do something like write file and then pass the output path, right? So how can we go about this? We could maintain the initial names that we have on the images, because we had that initially that we're loading that tensor. But for the purpose of this, I'm just gonna make something up. So like index of the image, it's gonna be index +1. So this is gonna be like image index, and then we'll do so the directory output path is going to be the directory plus augmented, and then the image number. right. And I never remember how this is supposed to be. Print output path. All right, yeah, so it seems like this is working. So this syntax here is to make add the leading zeros and okay. Well, I want to make a pause here. How's everyone going? Are you following? Is this been useful? Are you enjoying today? And if you have never joined us before, feel free to drop your name and where you're connecting from. All right, let's keep going. So I'm gonna make sure that the leading zeros are working. So we have now the paths of the images, and we can put here this thing. All the images are the same size, and we're getting the right names. So we know that this path doesn't exist. So we could say here output, maybe put it here outside. Output there is that, and this is the directory, and we can call here, I think it's OS make theirs, output there. All right, let's see if that works. If I do this, OS has to make theirs, maybe it is make theirs. Okay, so if we update here, so this function here, so we're constructing the path, the output directory path, and we're making sure that the operating system can create them before we save data to them. And now we have those here. So these are empty. These are empty directories, but we're going to save our augmented images to those directories. So now we have this code here. We can see that the path here would be, so output there, and file exists. Okay, and we need to do this. If OS let me check my notes. OS path exists. Okay, so OS path exists, output there. If not, okay. All right, so now we're getting the right path. Now we can try the decoding. So encoding the image as a JPEG and writing the files. And when we run that, cannot compute as input, was expected to be uinter, but is a float tensor. All right, a float tensor. Okay, so it seems that we need to cast our type, and I'm not sure when we want to do that, but I'm just going to try to do it here. So cast image to the D type uint8, and it keeps complaining. Code expected to be uint tensor, but it's a float tensor. All right, so let me see. So I've done this before as well, so this is like a refresher for me. Okay. Okay, let's try just doing this. Cannot compute and encode JPEG 0 based. Slow. Okay, so let's try printing that before. So print image. All right. Okay. So let me see, maybe we can just do this here. tf cast. Okay. It seems like this worked. So let's see if we have tensor conversion requests the data for string tensor with type, blah blah blah, the type float array. Convert image d type and pass this one d type tf uint 8. Oh, okay, my bad. I gotta do this here. Cool. Okay, well, it seems like at the end of the day this worked. Let me see. So if we got here the output path, so the output there, we can run something like this here. Okay, so these are the augmented images, but it seems like they are inverted. So we're gonna just try to do this. Maybe. Yeah, that doesn't look right. Okay, let's put the entire code in a single cell, just to make sure that we're able to run everything at once. So we might not need to do this. Right, that's really weird. Right, it looks a bit better. Okay, nice. I don't know why those edges are showing up there, which is really weird. But we're getting augmented images here. So if we now run this thing, and let's say we just don't limit the process, we're gonna get a bunch of images augmented, and this is just one operation, so a single operation per how can I say, per input image, right? So we're getting one of these augmentation per input image, but what we were doing before is that for each image, right, so we have the augmented batch here. For each image, we want to do this 9 times, right? So we'll have to add one more loop here. So for in range 9, and then we'll just move all of this block here, right? Yeah, and we'll have to add a second index. So this index, yeah, so this index here will be still outside, and then we'll do augmentation index, and this will be, so this is still will be here, and this will be that. That way, what we need to do now is just add here image index. So this would be augmentation index. All right. Wait, something is not working right now. So we have here images. So we are okay. So what we gotta do is first do this outside. So we just do this, we just get each image on the batch and get here our image index outside of the loop, and then augmented batch, no, augmented image. So image batch, we do text expand dims, we do our image axis 0, so this is image as batch, and yeah, so we get one image, we have our image as batch, this is going to be our input image, and then we just want to do remove this part, augmented image, and in here we'll just have our augmented image. Okay, right, let's see if this makes sense. I'll put myself here. So, and now the image index should go outside, and the augmentation index inside. You know, we could, okay. So we've made a batch, and okay, so let's do one thing. So we can say augmented batch. So let's rewrite this. So for I in range 9, right, we get our augmented batch is going to be data augmentation of our batch. And now we have for augmented image in augment, or let's do image in augmented batch. just get 2 of them. We're gonna print the augmented image shape. We'll leave this here. All right, so we'll just get the first one, and we won't open the folder for now. All right, for each image, we're doing that. Okay, so we're passing through the batch 9 times, so we don't need to do that. We just can go once and get the first image, and we'll include augmentations equals 1. So this is going to be the number of times that we augment our dataset, and we are now do in augmented image, in augmented batch. We do here our image index is 0. We do our image index plus 1, and then we would convert our image here. All right, so, and we have to build our output path, but this is our augmented image, augmented image, augmented image. All right, augmented image path is going to be this thing here. And we have our augmented index that is going to be here. All right, so let's see. So we will loop through augmentation. So we'll do an amount of augmentations that we'll get here. The index of the image will come here, and then we'll write the image, and we'll open the folder. All right, so 1 image, 1 augmentation. Now we want to do 9 augmentations for the first image. We're actually doing augmentations in all images, just saving the first one. All right, so this is the first image on the batch, and this is on the black and white one. And so now we're going to do them in all of them. So let's do, for instance, 3 augmentations per image and process the entire batch. Right, we don't really need to print the shape anymore, so we can delete this code as well. And it's ready. So now we can go and see, let me see if I can open this big. So for each image, we have here, what we can see is like 3 permutations, right? I don't really know how to get rid of this border. Let me just check. Yeah, I'm not really sure why the border happens. I'm not sure if anyone that is connected knows right now, but let's take a look here. So we have this is the Yeah, I'm not sure. Maybe my dataset has an outline for some reason, which I don't know, but it doesn't seem like it. I don't think that that's the case. All right. Anyhow, I'm gonna keep going, and I'm going to make sure that we can continue. So, all right, we got to where we wanted to get. That is having an augmented dataset, and we have now two images per image, right? Or actually three permutation for each sample. And what we're going to do is that we're going to use these images as well as the original ones as our augmented dataset. So let's go back now after an hour and a half into the original interface. So we had our original dataset, and we're going to go to that folder, so to the color augmented folder, and add all of them. So this is with three different modifications to each of the images. You see those edges are there. I don't really know how that's going to affect the training. It's going to, but and what I don't like is that might get confused. The network might be confused because those artifacts exist in both datasets. At the same time, that might tell the dataset to ignore it. All right, so let's just hit on here and train the model and see what happens. So under the hood, it's preparing the training data. Now we have more samples. We have 134 for color and 120 for black and white. And what I'm expecting is that the accuracy improves and the loss goes down. And it seems it's doing it. But at least, this means that it's working with the data set we're providing it. And again, my webcam went into the browser. We're not going to try to fight it right now. And all right, so let's try to get a file input instead of the webcam. And all right, well, first, before we do this, let's calculate the confusion matrix. So only one image is misclassified now, while before, and this is if we're getting what is it? Oh, we're getting what, 39 images, so one, so that's like 38, that's like 97% accuracy, which probably is up here, or 95 accuracy, 21 samples, 18 in here. So only one is getting misclassified as color from the gray data set. But at the end of the day, and you can see here the test accuracy is 97%, and the loss was going down. And it seems it's converging, but let's first try the model. So we try the model here with another of the test files, which before we already knew that was working well. But anyhow, yeah, so color being classified properly, and black and white classified perfectly. And let me see. All right, so this works. Let's see if we increase here this to 200 epochs and train the model, what happens. All right, so I think we're gonna wrap up soon. We didn't really go into let me just zoom into here so we can see that while we're training. It seems like we didn't really have the time to look at ML5.js. I can do a really quick example now, but it's worth an entire session, I think. And that's what we can do probably next week. And what we did today, we ended up doing something that represents a lot the reality of machine learning, is that we spent almost the entire session preparing a data set, doing data augmentation, just to try and see if we could reduce the loss and improve the accuracy of our of our classifier. It's heavier, it takes longer to train every epoch, but in this model is fairly small for us to, you know, not have it in mind. And with that, you know, we're here still training up to like maybe in 1.5 minutes we'll train 200 epochs, or 1 minute and 10 seconds. And what we have here that I'll try to also share is that we have a notebook that has the required code to do some data augmentation on a set of folders of images using the Keras sequential model with the new pre-processing experimental layers. As you can see, the important part here is that once we load the data set, and you know, we do this with list files method, we load all the paths of the images, of the input images, as strings, and then we run this load image function that we've defined above on each image. We read the file from the from disk with using the string path. We decode the images as JPEG, and making sure that we use 3 channels for the decoding. That's like black and white images that only have 1 channel get converted into 3. And then we resize 400 and 400 just for us to know that the batch size is going to be 400 and they're not going to be mismatching images. We can provide, I mean, this only works for this dataset because we want it to be 400, but we could actually have done here something like 2224, that is the data format of MobileNet, and save a bit of processing time on the web interface. These directories list, we could provide many folders and it will read all the images as JPEGs in this case and do that. And then we have that data augmentation model that we defined here. We just pass our images at the right moment. We just pass our images through that function when it's time, and we pass it a batch. The batch has like a shape of whatever number of images by 400, 403. And then we just do some, I mean, we construct make sure that the directory exists in which we're going to save the model, and then construct a path for an image that makes sense, and then convert the image from float back to uint8. Do some scaling to make sure that the colors are respected and the image doesn't add a lot of contrast as we saw before. And then we encode back the image to JPEG and write that data blob into a file on system on the augmentation image path. That's all in a nutshell of what we did today. You can see, let's maybe try to run the notebook once more with 224 by 224 and more augmentation. So we could say here 9, and we can go back to those folders and delete them. So I'm gonna put this side by side here and here. Right, so this is telling us that the directory got deleted, and we're gonna recreate it right now. And all right, so we have this here, and I'm just gonna run the entire notebook so we can run all cells, and this is now working and working faster because we put 224 instead of 400. And now we have a lot of images here. Sure, if I can do that. Doesn't care. Yep. All right. This is our augmented dataset. I don't really know how much augmentations you can do, but this actually represents different types of configurations of these images that you might see on the, you know, on new data that you export. So let me just make this quick thing here. And I'm just making a quick GIF as always. We have here, right. So this is a really pixelated version of what we've done today. So we've augmented a dataset using the tf.Dataset loader, or however that's called, the tf.Data.Dataset class. And this has served us to improve the accuracy and reduce the failures on the confusion matrix of our image classifiers. You can see these images are really pixelated because they're indeed just 224 by 124 pixels. And this is what you can expect that you can do if you don't have enough data to augment the data and have the model learn a bit better. All right, so Suje, okay, that's something we could try. So you mean that maybe the network is not learning properly because some of the images on the dataset have one channel instead of 3 channels? I think what would happen is that on the Teachable Machine website, when they do the pre-processing step, they probably are embedding this as part of their process. So they're probably decoding the images and making sure they're all RGB 3 channels and 224 by 224, right? So we could inspect that on the model, but I think that is the case. I think they probably do that already, and they won't let you really train with images that are black and white. But I might be wrong. We could try that some other day. I don't think I have time right now. And is that what you meant? Thanks for asking. So yeah, so we have our classifier here. We can export it as we did last time. Again, webcam goes into here. Well, now there is another image classified, but misclassified as gray instead of color. So as color instead of being gray. But the accuracy of color has gone up, so 1, and then gray has gone a bit down. Accuracy is still more or less the same, and what you can see in the loss per epoch is that we're not gaining that much. I mean, we're gaining, and we could go down on the test loss, but we might be also overfitting on this data set. All right, I'm gonna export the model to web to keep a link of it. Cool, and we'll copy this URL as well. With this operation, yeah, I mean, I guess like overfitting could be, I'm not sure. I mean, at the same time that you're changing the data and making it, so you're augmenting the dataset. So you're making sure that you're not just learning from the images that you have initially, right? So it means that you won't overfit to those drawings, right? Those drawings will be classified really well, but those are real drawings. We were using only 30 per class. Now, what we have is a model that has a lot more diversity in terms of the types of drawings that this might see. How we could avoid overfitting even better is like adding more real images to the dataset and also performing those augmentations. So both things, right? Adding more images and performing data augmentation techniques allow us to avoid overfitting on a set of data sets. But as always, the best thing is to add more real data into the model. And thanks for the question, Pedro. All right, so live 10. Right, we haven't covered many of the things that I was expecting to cover today, but I will just move them to next week. That way we have some content that we want to do next week. and we've more or less covered this. We didn't really cover this part, so maybe we can take a look at this as well. All right, anything else that you guys want to see next week if we do a live stream? Right, gonna do some housekeeping, make sure I leave everything we did today here. So data augmentation, and so let's make sure, is this a repo? Right. Maybe we can finish that React tab. Okay, so are you guys interested on looking at React? What would you like to see on React? Yeah, I think one of the topics that we could cover is how to use ML5 inside of React. That would be good because React, so at the end of the day, is just building a website, and ML5 is JavaScript, so we can use that in TypeScript or in React. Right, let me put this notebook here. Dataset raw. All right, let's commit this. Okay, and we're gonna push that. Oops. All right, so it seems we have done this, so live, and yeah, so we should keep a list of links here, probably of properly added links from each of the days and stuff, but for now I'm trying to do my best. You can see the data augmentation notebook that I created today if you go here to the repo. So let me just put the link there on the chat and also put it on the Discord channel. Well, you already probably have that. Live events. We might want to clean this up before right. Okay. Well, I think this is it for today. I just want to go and remember or remind you guys of something. So I have, outside of the live streams, I've prepared a small lecture and tutorial on how to do trainings on SageMaker, like a simplified version of what we saw a few weeks ago. So I'll be posting that soon as a reminder as well. Let me see if this works. Yeah, so we have this new episode is up. So I answered this question as I repeated many times. You can go to gettingsimple.com/ask to send questions to the podcast on the topics that relate to the podcast and previous episodes, and also to my writing. We have now, let me see if I can skip through this really quickly. So yeah, again, thanks guys for being there. And if you like the content, like the video, and if you are enjoying what you're seeing and you want to get notified when new videos are up, just feel free to subscribe and click the bell. And I will really encourage you to join the Discord community. We're just getting started, and it's a really good place to meet other people and talk about the different topics of the things we do, like machine learning, sketching, writing, podcasting, technology, creative coding, anything really. And yeah, thanks everyone for watching, and we'll see you next time. And one thing I want to remind you of is that we will be probably uploading trims of the videos that you've seen today here and on previous live streams on YouTube. So make sure to keep an eye on that. They will be, they'll be being added to the YouTube channel week by week. Yep. Bye everyone.